I'm grateful you joined tonight. Your brain has been working overtime today, burning through glucose reserves while stress hormones quietly accumulated in your bloodstream. Tonight, you'll discover what mental exhaustion actually does to your sleep architecture and understand why rest isn't weakness. It's survival. Welcome to Get Sleepy Science. Wherever you are right now, perhaps feeling that familiar fog of overwork, or noticing your thoughts running in exhausting circles, allow yourself to rest in this moment of pause. We'll journey through 100 psychology facts about mental exhaustion and sleep, from the tired neurons signaling for rest, to the sleep cycles fighting to repair what stress has damaged, to the moment your mind finally surrenders to healing darkness. These quiet journeys through mind science create a community of peaceful souls seeking rest. A gentle like, subscribe, or sharing your thoughts creates a pathway for more tired minds to discover and brings us closer to protect this sanctuary. One sleepy soul at a time. It means the universe to us. Settle deeper into your pillows now. Let your shoulders drop. Your breathing slow and steady. You don't need to hold on to any of this knowledge about exhaustion. Just feel that peaceful heaviness spreading through you, like your consciousness slowly dimming its brightness. Thoughts dissolving into the peaceful fog of approaching sleep, safe and undisturbed. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Mental exhaustion is not the same as physical tiredness. When your body is physically tired, your muscles have depleted their energy stores and accumulated metabolic waste products like lactic acid. Mental exhaustion, however, occurs when your brain's prefrontal cortex, the region responsible for decision-making, focus, and emotional regulation, has been overworked to the point of resource depletion. Recent 2024 research from the National Institutes of Health shows that prolonged cognitive demand causes a buildup of glutamate, an excitatory neurotransmitter, in the prefrontal cortex. When glutamate accumulates beyond normal levels, it can interfere with normal neuronal function, forcing the brain into a protective shutdown mode. This is why, after hours of intense mental work, even simple decisions feel impossible. Your brain isn't being lazy. It's protecting itself from cellular damage. Mental exhaustion is your nervous system's emergency brake. Your brain consumes about 20% of your body's total energy, despite representing only 2% of your body weight. The human brain weighs roughly 3 pounds. Yet it burns through approximately 320 calories per day, just maintaining basic functions. Thinking, processing emotions, forming memories, regulating your heartbeat and breathing. When you engage in intense mental work, problem solving, creative thinking, sustained attention, that energy demand increases significantly. A 2024 study, published in Nature Neuroscience, found that cognitively demanding tasks can increase brain glucose metabolism by up to 12% in the prefrontal and parietal regions, unlike your muscles, which can draw on fat reserves when glucose runs low. Your brain depends almost exclusively on glucose for fuel. When mental exhaustion sets in, you're experiencing genuine metabolic depletion in your neurons. The fog, the inability to focus, the irritability, these aren't character flaws. They're your brain running on fumes. Mental exhaustion activates your body's stress response system in the same way physical danger does. The hypothalamic pituitary adrenal axis, often called the HPA axis, is your body's central stress control system. When you face a deadline, a difficult conversation, or overwhelming workload, your hypothalamus releases corticotropin-releasing hormone, which signals your pituitary gland to produce adrenocorticotropic hormone, which then tells your adrenal glands to release cortisol and adrenaline. This cascade was designed for short-term physical threats, running from predators, fighting rivals. But chronic mental demands keep this system activated persistently. A 2025 meta-analysis in psychoneuroendocrinology found that people experiencing chronic work-related mental exhaustion show persistently elevated evening cortisol levels, a pattern that should naturally decline as bedtime approaches. Your body cannot distinguish between the stress of running from a lion and the stress of answering 50 emails. Both activate the same ancient survival machinery, and both make restful sleep nearly impossible. The default mode network in your brain becomes hyperactive when you're mentally exhausted. The default mode network, or DMN, is a collection of brain regions, including the medial prefrontal cortex, posterior cingulate cortex, and angular gyrus, that activate when you're not focused on the outside world. This network is responsible for self-reflection, mind wandering, thinking about the past and future, and processing social information. Under normal conditions, the DMN helps you consolidate memories and plan ahead. But when you're mentally exhausted, this network becomes overactive and poorly regulated. Functional MRI studies from 2024 show that exhausted individuals display excessive DMN activity that intrudes even during tasks requiring focused attention. This is why your mind wanders uncontrollably when you're tired, why you replay conversations obsessively, why worries loop endlessly. Your brain's self-referential thinking network is stuck in overdrive, unable to quiet itself. Mental exhaustion doesn't just tire you out, it traps you inside your own thoughts. Cognitive load theory explains why mental exhaustion accumulates throughout the day. Your working memory, the mental workspace where you temporarily hold and manipulate information, has limited capacity. Psychologist John Sweller's cognitive load theory, refined through decades of research, describes how our working memory can hold roughly 3 to 5 chunks of information simultaneously, depending on complexity. Every decision you make, every problem you solve, every social interaction you navigate adds to this cognitive load. A 2024 study in cognitive psychology found that decision fatigue, the deteriorating quality of decisions after a long session of decision-making, results from depletion of mental resources in the anterior cingulate cortex, a region that monitors for conflicts and errors. This is why judges are more likely to deny parole in the afternoon than the morning. Why you order takeout instead of cooking after work. Why choosing what to watch on television feels impossible at 9 p.m. Each choice, no matter how small, draws from the same limited reservoir. By evening, you're not weak-willed. You're neurologically depleted. Mental exhaustion disrupts your brain's ability to regulate emotions. The prefrontal cortex, particularly the ventromedial region, exerts top-down control over the amygdala, the brain's emotional alarm system. When you're well rested and mentally fresh, your prefrontal cortex can effectively dampen excessive emotional responses, helping you stay calm during frustration or stress. But mental exhaustion weakens this regulatory connection. A landmark 2024 study using functional connectivity (MRI) found that after sustained cognitive work, the coupling between the prefrontal cortex and amygdala significantly decreases. This means your emotional reactions become more intense and harder to control. Small frustrations feel overwhelming. Minor disappointments trigger disproportionate sadness. Everyday annoyances spark anger. This isn't emotional immaturity. It's a fatigued prefrontal cortex, losing its grip on the amygdala's alarm bells. Mental exhaustion makes the world feel more threatening, and your emotions feel more unmanageable because, neurologically, they are. Sleep pressure builds through a molecule called adenosine. Throughout your waking hours, your neurons are constantly active, firing electrical signals, releasing neurotransmitters, consuming energy. This neural activity produces adenosine as a metabolic byproduct. Adenosine accumulates in your brain throughout the day, binding to receptors in areas like the basal forebrain and gradually creating the sensation we call sleep pressure or sleepiness. Under normal circumstances, adenosine levels rise steadily from morning to night, promoting drowsiness by bedtime, then decrease during sleep as your brain clears it away. But mental exhaustion complicates this elegant system. Research from 2024 in Sleep Medicine Reviews shows that chronic stress and cognitive overload can dysregulate adenosine signaling, causing paradoxical patterns where you feel simultaneously exhausted and unable to sleep. Your brain is drowning in sleep pressure signals, but the stress hormones overriding the system keep you wired. You're tired beyond measure, yet sleep won't come. The anterior cingulate cortex acts as your brain's effort monitor. Nestled deep in the medial frontal cortex, the anterior cingulate cortex evaluates how much effort a task will require and whether the potential reward justifies that effort. It's essentially your brain's cost-benefit analyzer for mental work. When you're fresh, this region accurately assesses task difficulty and motivates appropriate effort. But under conditions of mental exhaustion, the anterior cingulate cortex becomes hypersensitive to effort demands. A 2025 study in Current Biology found that mentally fatigued individuals show exaggerated anterior cingulate activation, even for simple tasks, interpreting low-demand activities as requiring enormous effort. This is why replying to a simple email feels like climbing a mountain when you're exhausted. Why folding laundry seems impossibly complex. Why conversations require superhuman energy. Your brain's effort detection system is miscalibrated, making everything feel harder than it actually is. Mental exhaustion distorts your perception of difficulty itself. Mental exhaustion creates a state called cognitive inhibition failure. Cognitive inhibition is your brain's ability to suppress irrelevant information, unwanted thoughts, and automatic responses. It allows you to focus on what matters while ignoring distractions. This ability depends heavily on the dorsolateral prefrontal cortex, a region that fatigues quickly under sustained demand. Recent 2024 research in neuropsychology demonstrates that mental exhaustion significantly impairs inhibitory control, measured through tasks requiring participants to suppress automatic responses. When inhibition fails, intrusive thoughts break through more easily. Worries you successfully pushed aside in the morning return with intensity at night. Negative memories surface unbidden. Rumination becomes uncontrollable. This isn't a lack of mental discipline. It's a fatigued prefrontal cortex, unable to guard the gates of consciousness. Mental exhaustion opens the doors to thoughts you'd rather keep locked away. So yes, mental exhaustion is already changing our understanding by showing us that tiredness exists on multiple dimensions. We now know that you can be physically energized yet mentally depleted, or physically exhausted yet mentally alert. The fatigue you feel after a day of intense cognitive work is fundamentally different from the fatigue after running a marathon. Both are real. Both are measurable in the brain. And both deserve recognition and rest. Mental exhaustion isn't invisible or imaginary. It's written in your neurotransmitter levels, your brain metabolism, your neural connectivity patterns. Science is finally validating what you've always felt. Thinking is work. And thinking all day without rest is exhausting. Chronic mental exhaustion can lead to a state called ego depletion. The concept, developed by psychologist Roy Baumeister, suggests that self-control draws from a limited resource that becomes depleted with use. While the original theory has been refined, 2024 research supports a modified version. Sustained self-regulation efforts, resisting temptations, suppressing emotions, making difficult choices, do impair subsequent self-control, particularly under conditions of cognitive load and stress. Brain imaging shows that repeated acts of self-control reduce activity in the anterior cingulate cortex and lateral prefrontal cortex, regions crucial for willpower. This explains why your healthiest intentions crumble in the evening, why you reach for comfort food after a stressful day, why you scroll social media instead of reading before bed. You haven't failed morally. You've depleted the neurological resources required for self-discipline. Mental exhaustion makes restraint biologically harder. Your working memory capacity shrinks when you're mentally exhausted. It's a cognitive system that allows you to hold information in mind while using it, like remembering a phone number while dialing, or keeping track of ingredients while cooking. It's essential for reasoning, learning, and comprehension. The capacity of working memory is limited, typically holding about 3 to 5 items simultaneously depending on task complexity. But this capacity is not fixed. It fluctuates based on your mental state. A comprehensive 2024 meta-analysis in Psychological Bulletin found that mental fatigue reduces working memory capacity by approximately 15 to 25%, with the largest impairments in tasks requiring simultaneous storage and processing. This is why following complex instructions feels impossible when you're tired, why you lose track of conversations, why you read the same paragraph 3 times without comprehension. Your mental workspace has physically contracted. Mental exhaustion doesn't just slow your thinking. It reduces the amount you can think about at once. Mental fatigue alters your brain's reward processing system. The ventral striatum, particularly a region called the nucleus accumbens, plays a central role in anticipating and experiencing pleasure and reward. This system motivates you toward goals by making their achievement feel satisfying. Under normal conditions, anticipating a reward, a delicious meal, a social connection, a completed project, activates the nucleus accumbens and releases dopamine, driving motivation. but mental exhaustion dampens this system. A 2025 study using PET imaging found that cognitively fatigued individuals show reduced dopamine release in the ventral striatum in response to reward anticipation. This blunting of reward sensitivity explains why nothing sounds appealing when you're exhausted, why activities you normally enjoy feel flat, why even relaxation feels like too much effort. Your brain's pleasure system is temporarily offline. Mental exhaustion steals not just your energy, but your capacity for enjoyment. The phenomenon of decision fatigue has been documented in judges, doctors, and parole boards. A famous 2011 study, still referenced and replicated in 2024 research, examined over 1,000 judicial rulings and found a striking pattern. The likelihood of a favorable ruling dropped dramatically as the day progressed, returning to morning levels only after meal breaks. Judges were significantly more likely to grant parole early in the morning than late in the afternoon, regardless of the severity of the crime. This isn't evidence of judicial bias. It's evidence of mental exhaustion. Making decisions requires mental effort, and that effort depletes cognitive resources. After hundreds of decisions, the brain defaults to the easier option, which in legal contexts often means maintaining the status quo, denying parole, refusing bail. Similar patterns appear in medical decisions, financial choices, and consumer behavior. Mental exhaustion doesn't just cloud your judgment, it systematically biases you toward easier, safer, more conservative choices. Mental exhaustion triggers inflammation in your brain. Microglia, the immune cells of the central nervous system, normally patrol the brain looking for damaged cells and foreign invaders. Under healthy conditions, they support neuronal health and synaptic pruning. But chronic stress and mental overload can shift microglia into a pro-inflammatory state. A groundbreaking 2024 study in brain, behavior, and immunity found that participants experiencing work-related burnout showed elevated markers of neuroinflammation, including increased levels of inflammatory cytokines like interleukin-6 and tumor necrosis factor alpha in cerebrospinal fluid. This neuroinflammation can impair synaptic function, reduce neuroplasticity, and interfere with the brain's ability to clear metabolic waste. Mental exhaustion isn't just a psychological state. It's an inflammatory condition affecting your brain tissue. Your exhausted mind is, quite literally, inflamed. The glymphatic system, your brain's waste clearance network, operates primarily during sleep. Discovered in 2012 and extensively mapped in subsequent years, the glymphatic system uses cerebrospinal fluid to flush metabolic waste products from the brain. During sleep, particularly deep sleep, the spaces between brain cells expand by up to 60%, allowing cerebrospinal fluid to flow more freely and sweep away proteins like beta amyloid and tau. Recent 2024 research shows that chronic sleep disruption, common in mental exhaustion, severely impairs glymphatic clearance. When you don't sleep well, these waste products accumulate, further impairing cognitive function and creating a vicious cycle. Mental exhaustion disrupts sleep. Poor sleep reduces waste clearance. Accumulated waste worsens exhaustion. Your brain needs sleep not just for rest, but for essential housekeeping. Mental exhaustion that prevents sleep is like never taking out the trash. Eventually, the buildup impairs brain function, Cognitive flexibility, the ability to switch between tasks and adapt to new information, deteriorates rapidly under mental fatigue. Cognitive flexibility depends on networks involving the prefrontal cortex, anterior cingulate cortex, and basal ganglia. These regions allow you to shift mental gears, abandon ineffective strategies, and adjust to changing circumstances. A 2024 study in Frontiers in Psychology used task-switching paradigms to measure cognitive flexibility in mentally fatigued participants. Results showed that exhaustion significantly increased switch costs, the time and accuracy penalties when shifting between tasks, and reduced the ability to inhibit no longer relevant task sets. This is why multitasking becomes impossible when you're tired, why you get stuck in unproductive patterns, why adapting to unexpected changes feels overwhelming. Your mental gearbox has frozen. Mental exhaustion makes you rigid when the world demands flexibility. Time perception distorts under mental exhaustion. Your subjective experience of time passing relies on attention, memory encoding, and the brain's internal clock mechanisms involving the basal ganglia and cerebellum. When you're mentally engaged and experiencing novelty, time seems to expand because you're encoding rich, detailed memories. Conversely, when you're exhausted and functioning on autopilot, time seems to collapse because you're forming fewer distinct memories. A 2025 study in timing and time perception found that mentally fatigued individuals consistently underestimate how much time has passed during rest periods and overestimate duration during cognitive tasks. This means when you're exhausted, work feels endless, while rest feels fleeting. Hours of effortful thinking stretch interminably, while moments of potential recovery flash by unnoticed. Mental exhaustion warps your relationship with time itself, making suffering feel eternal and relief feel impossible to sustain. Mental exhaustion reduces your capacity for empathy and social cognition. Understanding others' mental states, their beliefs, intentions, emotions, requires the medial prefrontal cortex, temporoparietal junction, and superior temporal sulcus. These regions form the social brain network. When fresh, you can easily perspective take, interpret subtle social cues, and respond appropriately to others' emotions. But mental fatigue impairs this network. A 2024 study in social, cognitive, and affective neuroscience found that cognitively depleted participants showed reduced activity in social brain regions and performed worse on theory of mind tasks, struggling to infer others' mental states. This is why you misread social situations when tired, why you seem cold or dismissive, why you can't muster sympathy for others' problems. You haven't become selfish. Your social cognition network is temporarily offline. Mental exhaustion makes connection harder precisely when you need it most. Your brain's salience network, which detects what's important and deserves attention, becomes dysregulated under chronic stress. The salience network includes the anterior insular and anterior cingulate cortex. It acts as a switchboard, determining whether to activate the executive control network for focused work or the default mode network for internal reflection. Normally, the salience network helps you distinguish genuine priorities from trivial distractions. But mental exhaustion disrupts this system. A 2024 study in neuroimage found that chronically stressed individuals show aberrant salience network connectivity, causing them to either overreact to minor stressors or underreact to genuinely important information. This explains why everything feels urgent when you're exhausted. Why you can't tell the difference between a real crisis and a minor inconvenience. Why you panic about trivial matters while ignoring serious issues. Your brain's priority detection system has lost calibration. Mental exhaustion makes you unable to distinguish what truly matters. Sleep inertia, the grogginess upon waking, intensifies when you're mentally exhausted. Sleep inertia occurs because different brain regions wake up at different rates. The brainstem and thalamus activate quickly, bringing basic consciousness. But the prefrontal cortex, responsible for complex thinking and decision-making, takes longer to come fully online. This is normal and usually dissipates within 15 to 30 minutes. However, research from 2024 in sleep shows that individuals experiencing chronic mental exhaustion display prolonged and severe sleep inertia, sometimes lasting over an hour, with persistent cognitive impairment during this period. Brain imaging reveals that their prefrontal cortex remains in a sleep-like state significantly longer. This means when you're mentally exhausted, mornings are especially brutal, not because you're lazy, but because your thinking brain is still partially asleep. The deeper your exhaustion, the harder your brain fights waking up. Mental exhaustion alters your interoceptive awareness, your ability to sense internal bodily states. The insula, particularly the anterior portion, integrates signals from throughout your body, creating your felt sense of hunger, thirst, heart rate, muscle tension, and emotional arousal. This internal awareness helps you recognize when you need food, rest, or care. But chronic stress and mental overload can impair insular function. A 2025 study in psychosomatic medicine found that burnout is associated with reduced interoceptive accuracy, meaning exhausted individuals have difficulty identifying their own physical and emotional needs. This is why you forget to eat when overwhelmed, why you don't notice rising stress until you're in crisis, why you push past obvious exhaustion signals. Your brain has lost touch with your body's messages. Mental exhaustion severs the communication between mind and body, leaving you disconnected from your own needs. The concept of time pressure creates measurable cognitive costs. Even when you have sufficient time to complete a task, simply believing you're under time pressure activates stress responses and impairs performance. A fascinating 2024 meta-analysis in psychological science examined dozens of studies on time pressure and found that perceived time scarcity reduces working memory capacity, increases errors, and promotes shallow rather than deep processing of information. The mere thought that time is running out activates your amygdala and hypothalamus, triggering cortisol release and narrowing attention to immediate threats rather than long-term goals. Modern work culture's obsession with urgency and productivity creates chronic perceived time pressure, keeping workers in a state of persistent, low-level activation. This isn't motivating. It's cognitively draining. Mental exhaustion thrives in environments where time itself feels like an adversary. Your brain's capacity for creative insight diminishes when you're mentally exhausted. Creative problem-solving often involves the aha moment, when disparate pieces of information suddenly connect in a novel way. This process requires the right hemisphere's associative networks and the anterior cingulate cortex, detecting remote connections. Research from 2024 in Thinking and Reasoning demonstrates that mental fatigue significantly reduces creative insight, problem solving, while having less effect on analytical problem solving. When you're exhausted, you can still grind through logical steps, but those moments of inspiration evaporate. Your brain defaults to familiar, conventional solutions because making novel connections requires cognitive resources you no longer have. This is why your best ideas come in the shower or during walks. When your mind is rested and free to wander, mental exhaustion doesn't just make you slower. It makes you less creative, less innovative, less capable of breakthrough thinking. Pattern emerging. These observations reveal that mental exhaustion is not a single phenomenon, but a constellation of interconnected neurological, hormonal, and cognitive disruptions. From glutamate accumulation in exhausted neurons to inflammation in brain tissue, from dampened reward systems to impaired social cognition. Exhaustion touches every aspect of mental function. Your tired mind isn't a character flaw or moral failure. It's a biological system pushed beyond its operational limits, exhibiting predictable patterns of breakdown. And crucially, each of these disruptions feeds into and amplifies the others, creating cascading failures that make both productivity and rest increasingly difficult. We're beginning to understand that mental exhaustion changes everything, including, most critically, your ability to sleep. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence. Heart beating, lungs breathing, brain thinking, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-balancing. Now we continue. Mental exhaustion specifically disrupts REM sleep, the stage where emotional processing occurs. REM sleep, characterized by rapid eye movements, vivid dreams, and temporary muscle paralysis, typically occupies about 20 to 25% of your total sleep time. During REM, your brain processes emotional experiences, consolidates certain types of memories, and appears to rehearse responses to potential threats in a safe environment. The amygdala and hippocampus are highly active during REM, while the prefrontal cortex remains relatively quiet. This allows emotional memories to be reprocessed without the intense physiological arousal that accompanied the original experience. A landmark 2024 study in Nature Sleep found that individuals with chronic work-related stress show fragmented REM sleep with frequent awakenings during REM periods and reduced total REM duration. When mental exhaustion disrupts REM, you lose the very sleep stage designed to help you recover emotionally from the stress causing your exhaustion. It's a cruel paradox. The more you need emotional processing, the less REM sleep you get. Sleep fragmentation, characterized by brief awakenings throughout the night, becomes more common when you're mentally exhausted. Even if you sleep for 8 hours, frequent interruptions prevent you from completing full sleep cycles. Each sleep cycle lasts roughly 90 minutes and progresses through light sleep, deep sleep, and REM sleep in sequence. Completing multiple uninterrupted cycles is essential for restorative sleep. But chronic stress keeps your nervous system in a hypervigilant state. A 2024 study using home polysomnography found that stressed individuals experienced an average of 15 to 25 brief arousals per hour in severe cases. Micro-awakenings lasting only 3 to 10 seconds, often unremembered but still disruptive. These arousals prevent progression into deeper sleep stages and create a sensation of light, unrefreshing sleep even with adequate time in bed. Brainwave analysis showed that these individuals spent significantly more time in stage 1 and stage 2 light sleep and less in restorative slow-wave sleep. Mental exhaustion keeps you skimming the surface of sleep, never diving into the deep waters where true rest lives. Cortisol, your primary stress hormone, follows a daily rhythm that mental exhaustion disrupts. Normally, cortisol peaks shortly after waking, providing energy and alertness for the day ahead, then gradually declines throughout the day, reaching its lowest point around midnight. This circadian pattern is controlled by your suprachiasmatic nucleus, the brain's master clock. Low evening cortisol facilitates the transition to sleep. However, chronic mental stress flattens this rhythm. A comprehensive 2024 meta-analysis in psychoneuroendocrinology found that burnout is associated with elevated evening cortisol and blunted morning cortisol, essentially a reversed pattern. High cortisol at bedtime promotes wakefulness by increasing heart rate, blood pressure, and glucose availability, while low morning cortisol leaves you feeling sluggish and unrefreshed despite having slept. Your stress system is stuck broadcasting danger at night when it should be whispering safety. Mental exhaustion doesn't just make falling asleep harder, it inverts your natural biological rhythms. The sleep hormone melatonin gets suppressed by stress and artificial light exposure. Both common in modern exhaustion, melatonin is produced by the pineal gland in response to darkness, signaling to your body that it's time for sleep. Light exposure, particularly blue wavelength light from screens, powerfully suppresses melatonin production. But stress itself also inhibits melatonin synthesis through cortisol-mediated pathways. A 2024 study in the Journal of Clinical Sleep Medicine found that individuals experiencing high work-related stress showed delayed melatonin onset and reduced peak melatonin levels, independent of light exposure. Moreover, the combination of stress and evening screen use created additive suppression effects, each factor making the other worse. When you're mentally exhausted, you often turn to screens for distraction, unknowingly sabotaging the very hormone that could help you sleep. Your body is trying to signal rest, but stress and screens are drowning out the signal. Sleep pressure and circadian rhythm normally work together to promote sleep, but mental exhaustion disrupts this coordination. Sleep pressure, driven by adenosine accumulation, creates increasing drowsiness across your waking hours. Your circadian rhythm, controlled by the suprachiasmatic nucleus, promotes sleep during your biological night. Ideally, these two systems align so that peak sleep pressure coincides with your circadian sleep window. But chronic stress can desynchronize these systems. Recent 2024 research in Current Biology shows that prolonged stress exposure can shift circadian phase later, while simultaneously impairing adenosine clearance during sleep, creating a mismatch. You feel exhausted in the evening but wired at bedtime, then drowsy in the morning when you need alertness. This phenomenon, called paradoxical insomnia or hyperarousal, explains why severe exhaustion often makes sleep feel impossible rather than inevitable. Your sleep systems are out of sync, fighting each other instead of working together. The arousal system in your brainstem stays activated when it should power down. Your sleep-wake cycle is controlled by opposing neural networks. Wake-promoting regions in the brainstem, hypothalamus, and basal forebrain release neurotransmitters like norepinephrine, histamine, and orexin, while sleep-promoting regions in the hypothalamus release GABA. These systems function like a switch, with wake and sleep mutually inhibiting each other. Normally, as bedtime approaches, sleep-promoting regions gradually gain strength, flipping the switch to sleep. But mental exhaustion and stress keep wake-promoting regions hyperactive. A 2025 study using functional MRI found that insomnia patients with stress-related hyperarousal showed persistent activation in the locus coeruleus, the brain's primary norepinephrine center, even during attempted sleep. Their brains couldn't flip the switch because the wake system refused to power down. Mental exhaustion creates a neurochemical state incompatible with sleep initiation, no matter how tired you feel. Your heart rate variability, an indicator of nervous system balance, decreases during chronic stress and predicts poor sleep. Heart rate variability, or HRV, measures the variation in time between consecutive heartbeats. High HRV indicates a healthy, flexible autonomic nervous system that can appropriately shift between sympathetic, fight or flight, and parasympathetic, rest and digest, activity. Low HRV suggests chronic sympathetic dominance, your nervous system stuck in stress mode. A 2024 longitudinal study published in Sleep Medicine tracked HRV and sleep quality in over 500 participants for 6 months. Results showed that declining HRV preceded worsening sleep quality by several weeks, and that low nighttime HRV strongly predicted fragmented sleep and early morning awakenings. Your heart's rhythm reflects your nervous system state, and mental exhaustion locks that system in high alert. The irregular, rapid-fire heartbeat pattern keeps your brain vigilant when it should surrender to sleep. Mental exhaustion increases the latency to REM sleep, the time it takes to enter your first REM period. Under normal conditions, your first REM period occurs roughly 70 to 90 minutes after sleep onset, but stress and exhaustion can delay REM onset significantly. A 2024 study examining polysomnography data from stressed workers found that their first REM period often didn't occur until 120 minutes or more after sleep onset, and in some cases was entirely absent from the first sleep cycle. This delay matters because REM sleep is crucial for emotional regulation and memory consolidation. By the time stressed individuals finally entered REM, they had less total REM time remaining before morning awakening. Moreover, the REM sleep they did achieve was lighter and more fragmented. Mental exhaustion doesn't just reduce sleep quantity, it specifically robs you of the sleep stage most important for recovering from stress itself. The transition from wakefulness to sleep involves a gradual decline in core body temperature, which stress disrupts. Your circadian rhythm controls body temperature, with core temperature dropping about 1 to 2 degrees Fahrenheit during the night, reaching its lowest point in the early morning hours. This temperature decline facilitates sleep onset by promoting melatonin release and reducing metabolic rate. However, stress hormones like cortisol and adrenaline maintain higher metabolic activity and body temperature, A 2024 study in Physiology and Behavior used continuous temperature monitoring and found that stressed individuals showed delayed and blunted nighttime temperature decline, with core temperature remaining elevated well into the night. Your body stays metabolically active when it should be cooling and quieting. This is why hot, restless nights often accompany periods of high stress. Mental exhaustion keeps your internal thermostat set too high for comfortable sleep. Sleep spindles, brief bursts of brain activity during stage 2 sleep, become less frequent under chronic stress. Sleep spindles are 12 to 15 Hz oscillations that last half a second to 2 seconds and appear to play important roles in memory, consolidation, and sensory gating, blocking out external disturbances to maintain sleep. The thalamus generates these spindles, which then propagate to the cortex. Recent 2024 research using high-density EEG found that individuals experiencing burnout showed significantly reduced spindle density, particularly in frontal brain regions. Fewer spindles meant both poorer memory consolidation and increased susceptibility to awakening from noise or other disturbances. Even when mentally exhausted, people manage to fall asleep. Their sleep is less protective and less restorative because these critical oscillations are diminished. Your brain can't fully disconnect from the outside world. New understanding. These evidence patterns suggest that mental exhaustion affects sleep quality through multiple independent mechanisms. It's not just one broken system. It's dysregulated cortisol, suppressed melatonin, persistent arousal, elevated temperature, fragmented REM, reduced spindles, and desynchronized circadian rhythms, all happening simultaneously. Each mechanism alone could impair sleep. Together, they create a nearly impenetrable barrier to rest. This is why simple sleep hygiene advice often fails for exhausted individuals. Telling someone to just relax or go to bed earlier ignores the biological reality that their sleep machinery is fundamentally disrupted at multiple levels. Mental exhaustion doesn't just make you tired. It systematically dismantles your capacity for restorative sleep. The orexin system, which promotes wakefulness, becomes dysregulated during chronic stress. Orexin, also called hypocretin, is a neuropeptide produced by neurons in the lateral hypothalamus. Orexin neurons send projections throughout the brain, promoting wakefulness by exciting arousal centers and inhibiting sleep-promoting regions. Normally, orexin activity is high during wakefulness and low during sleep, but stress can disrupt this pattern. A 2025 animal study in sleep, since replicated in human neuroimaging studies, found that chronic stress increases orexin neuron activity and orexin receptor sensitivity in arousal centers. Even worse, stress prevents the normal nighttime suppression of orexin, keeping these wake-promoting neurons firing when they should be silent. This explains why racing thoughts and physical restlessness plague bedtime during stressful periods. Your brain's wakefulness chemical won't shut off. Mental exhaustion overactivates the very system designed to keep you awake. Slow-wave sleep, the deepest and most restorative sleep stage, decreases significantly during periods of high stress. Slow-wave sleep, also called deep sleep or stage 3, is characterized by high amplitude, low-frequency delta waves on EEG. This stage is crucial for physical restoration, immune function, and clearing metabolic waste from the brain. Growth hormone is primarily released during slow-wave sleep, facilitating tissue repair. Normally, slow-wave sleep is most abundant in the first third of the night. A comprehensive 2024 meta-analysis, combining data from over 2,000 participants, found that chronic stress reduces slow-wave sleep duration by an average of 30 to 40%, with some highly stressed individuals showing almost complete absence of deep sleep. Brain imaging revealed that stress keeps the anterior cingulate and prefrontal cortex active during what should be deep sleep, preventing the full deactivation necessary for delta wave generation. Without deep sleep, your body can't perform essential maintenance. Mental exhaustion robs you of your most healing sleep. The relationship between sleep and the immune system becomes disrupted by chronic mental stress. Sleep and immunity are bidirectionally connected. Poor sleep weakens immune function, while inflammation disrupts sleep. During healthy sleep, particularly slow-wave sleep, your immune system releases cytokines that promote both immune defense and sleep depth. But chronic stress creates a vicious cycle. Elevated cortisol suppresses immune function, while simultaneously promoting inflammatory responses. A 2024 study in brain, behavior, and immunity found that stressed individuals showed elevated inflammatory markers, IL-6, TNF-alpha, CRP, at bedtime, which correlated with fragmented sleep and reduced slow-wave sleep. The inflammation then further disrupted sleep architecture, perpetuating the cycle. You're caught in a feedback loop where exhaustion creates inflammation. Inflammation prevents deep sleep, and lack of deep sleep worsens exhaustion and inflammation. Your mind's tiredness becomes your body's sickness. By this point in our exploration, the answer is emerging. Mental exhaustion doesn't just make falling asleep difficult. It fundamentally alters sleep structure, depth, and restorative capacity. Every component of healthy sleep, from initial drowsiness to deep sleep to REM to morning awakening, becomes compromised. The stressed brain simultaneously generates intense sleep pressure while blocking access to sleep itself, creating the torturous state of being exhausted yet unable to rest. Understanding these mechanisms helps explain why sleep feels so elusive during difficult times. It's not a personal failing. It's neurobiology. You're still here, thoughts still flickering like candlelight. Just notice where your mind is. No judgment needed. We're exploring consciousness itself, the very thing doing the exploring. Strange, beautiful, perfectly calm. Let's drift onward together. Poor sleep reduces your capacity for self-regulation the next day, making healthy choices harder, intensifying reactions to stress, which then disrupts that night's sleep. When you sleep poorly, your prefrontal cortex shows reduced activity the following day, particularly in regions that regulate impulses and emotions. This means small frustrations trigger disproportionate responses. Conflicts escalate more easily, and intentional choices become difficult. These struggles create more stress, leading to another night of poor sleep. A 2024 longitudinal study in emotion tracked this pattern across 3 weeks, finding that poor sleep predicted next-day self-regulation difficulties, which predicted increased evening stress, which predicted that night's poor sleep. Each element feeds forward, creating a downward spiral. Breaking free requires interrupting the cycle at any point. but exhaustion makes intervention feel impossible. Sleep deprivation impairs your ability to accurately assess your own impairment. This phenomenon, called metacognitive failure, means that when you're exhausted, you lose the capacity to recognize how exhausted you are. Research from 2024 in Consciousness and Cognition found that sleep-deprived individuals consistently overestimate their performance on cognitive tasks, rating themselves as more alert and capable than objective measures indicate. Brain imaging showed reduced activation in the medial prefrontal cortex, a region involved in self-awareness and self-monitoring. This is why exhausted people insist they're fine and push harder instead of resting. Your internal gauge is broken. Mental exhaustion blinds you to your own deterioration, making you unable to recognize when you've crossed from productive to destructive. The expectation of poor sleep can itself impair sleep quality, creating a self-fulfilling prophecy. If you approach bedtime expecting to struggle, that anxiety activates your stress response and promotes arousal. This phenomenon, studied extensively in insomnia research, is called sleep anticipatory anxiety. A 2024 intervention study in behavior research and therapy found that individuals with chronic insomnia showed elevated cortisol and heart rate beginning an hour before their typical bedtime, even on nights when they took sleep medication. Their bodies had learned to associate bedtime with struggle and began the stress response preemptively. The anxiety about not sleeping becomes its own cause of sleeplessness. Mental exhaustion creates legitimate sleep difficulties, which create worry about sleep, which creates more sleep difficulties. You become trapped in a loop of fear and insomnia. Compensatory behaviors like caffeine use and napping can perpetuate poor sleep patterns. When you sleep poorly, you naturally reach for caffeine to maintain alertness. But caffeine has a half-life of about 5 to 6 hours, meaning that coffee consumed at 3 p.m. still has half its caffeine circulating at 9 p.m., blocking adenosine receptors and reducing sleep pressure. Similarly, long or late-day naps reduce homeostatic sleep drive, making nighttime sleep onset more difficult. A 2024 analysis of sleep diary data from shift workers found that caffeine consumption after 1 p.m. and naps longer than 30 minutes both predicted worse nighttime sleep that evening, which then predicted more caffeine and napping the next day. These behaviors feel necessary to cope with exhaustion, but unknowingly extend the cycle. You're borrowing wakefulness from tomorrow's sleep to pay for today's exhaustion. Chronic partial sleep restriction accumulates a sleep debt that takes weeks to repay. Most people need 7 to 9 hours of sleep per night. If you consistently get 6 hours, you're accruing a 1 to 3 hour deficit each night. A landmark 2024 study in sleep tracked participants restricted to 6 hours for 2 weeks. By the end, their cognitive performance matched individuals who had been totally sleep deprived for 2 days. Yet they reported only moderate sleepiness, illustrating metacognitive failure. When allowed recovery sleep, participants slept longer than baseline for over a week, and some cognitive deficits persisted even after 3 weeks of recovery. The brain doesn't simply reset after one good night. Chronic exhaustion creates a debt that demands lengthy repayment. Weekend sleep-ins cannot undo weeks of stress and short sleep. The ventrolateral preoptic nucleus, your brain's sleep switch, becomes less responsive with chronic stress. This cluster of neurons in the hypothalamus promotes sleep by releasing GABA, which inhibits wake-promoting regions. When these neurons are active, you sleep. When they're inactive, you wake. Stress hormones and inflammatory signals can impair these neurons' function. A 2025 animal study in the Journal of Neuroscience, with implications for human sleep, found that chronic stress reduced the excitability of ventrolateral preoptic neurons, making them harder to activate. Even when all the right conditions for sleep were present: darkness, quiet, safety. The sleep switch required more and stronger signals to flip. Mental exhaustion raises the threshold for sleep initiation, meaning you need to be more tired, more relaxed, and more comfortable than normal to fall asleep. The bar keeps rising. Ruminative thinking, common in mental exhaustion, directly interferes with the transition to sleep. Rumination involves repetitively focusing on negative emotions, problems, or past events without moving towards solutions. This cognitive pattern activates the default mode network and maintains cortical arousal. A 2024 study using pre-sleep thought sampling found that individuals with high levels of rumination took significantly longer to fall asleep and showed persistent beta wave activity associated with active thinking on EEG, even after reported sleep onset. Their minds were churning when their brains should be quieting. Rumination serves no functional purpose at bedtime. Problems cannot be solved in the dark. Yet exhaustion makes it nearly impossible to stop. Your tired mind gets stuck in loops, replaying failures and rehearsing anxieties, each repetition driving you further from sleep. The perceived pressure to fall asleep creates performance anxiety that prevents sleep. When sleep becomes something you must achieve, it transforms from a natural biological process into a stressful task. This paradox, that trying to sleep makes sleep harder, is well documented in clinical sleep research. A fascinating 2024 experimental study told one group of participants they would be tested on cognitive performance the next morning and needed good sleep, while telling a control group nothing. The pressured group took significantly longer to fall asleep and showed higher cortisol throughout the night, despite identical sleep environments. When sleep carries consequences, the stakes make relaxation impossible. Mental exhaustion often comes with real demands: work deadlines, responsibilities, survival needs that make sleep feel deeply necessary, which makes sleep feel more distant. You need sleep profoundly, which is precisely what makes relaxation feel harder to reach. Social jet lag. The mismatch between biological and social sleep timing worsens under chronic stress. Most people's natural circadian rhythm prefers slightly later sleep and wake times than work and school schedules demand. This mismatch is called social jet lag. During the week, you sleep according to your alarm clock. On weekends, you sleep according to your biology. The constant shifting between schedules disrupts circadian alignment. A 2024 population study in Chronobiology International found that individuals experiencing high work stress showed greater social jet lag, sleeping up to 3 hours later on weekends than weekdays in an attempt to catch up. But this pattern further destabilizes circadian rhythms and makes Monday morning sleep quality even worse. Exhaustion drives you to seek weekend recovery sleep, but the timing mismatch compounds your circadian dysfunction. You're perpetually jet-lagged without ever boarding a plane. Halfway through our journey, the answer is emerging clearly. Mental exhaustion and sleep problems create a bidirectional, self-perpetuating cycle. Poor sleep impairs the very cognitive and emotional capacities needed to manage stress effectively. Impaired stress management generates more mental exhaustion. Exhaustion disrupts sleep even further. Each night of poor sleep makes you more vulnerable to stress. Each stressful day makes you more vulnerable to poor sleep. Breaking this cycle requires recognition that rest is not a luxury or reward for productivity. It's a biological necessity for maintaining the systems that allow productivity to exist. Yet exhaustion steals your ability to rest, creating a trap that tightens with each rotation. Take a moment to feel your breath, in and out. Notice how your body rests, supported completely by what's beneath you. Let each breath guide you to realize time is yours, a separate stream that only you are living. While the vast universe continues to spin, this second you're breathing is unique. Cherish the present moment. And we continue drifting. Cognitive behavioral therapy for insomnia, or CBT-I, has been shown to break the exhaustion sleep cycle more effectively than medication. CBT-I addresses the thoughts and behaviors that perpetuate poor sleep. Components include sleep restriction, temporarily limiting time in bed to match actual sleep time, then gradually extending. Stimulus control, associating bed with sleep, not wakefulness. Cognitive restructuring, challenging catastrophic beliefs about sleep. And relaxation training. A comprehensive 2024 meta-analysis in The Lancet Psychiatry analyzed 87 randomized controlled trials and found that CBT-I produced sustained improvements in sleep quality, with effects lasting years beyond treatment. Medications may support sedation in the short term, while CBT-I addresses underlying patterns. Breaking the cycle requires not just treating symptoms, but rewiring the patterns that create them. Progressive muscle relaxation reduces physiological arousal and facilitates sleep onset. This technique involves systematically tensing and then releasing muscle groups throughout the body, typically starting with the feet and moving upward. The tension-release contrast enhances awareness of muscle relaxation and activates the parasympathetic nervous system. A 2024 randomized trial in applied psychophysiology and biofeedback found that participants practicing progressive muscle relaxation before bed showed reduced cortisol, decreased heart rate, and faster sleep onset compared to controls. Brain imaging revealed increased activation in the parasympathetic promoting regions of the brainstem and reduced amygdala activity. The beauty of this technique is its simplicity and portability. No equipment needed, just attention to your own body. By deliberately releasing physical tension, you signal safety to your nervous system, inviting the shift from arousal to rest. Mindfulness meditation alters brain structure in regions involved in stress and emotion regulation. Mindfulness involves paying attention to present moment experience without judgment, typically focusing on breath, bodily sensations, or sounds. Regular practice has been shown to increase gray matter density in the hippocampus and prefrontal cortex while reducing amygdala volume. A landmark 2024 longitudinal study in biological psychiatry followed mindfulness practitioners for 6 months with structural MRI scans. Results showed measurable increases in prefrontal cortex thickness and strengthened connectivity between prefrontal regions and the amygdala, precisely the connections that mental exhaustion weakens. Participants also reported improved sleep quality and reduced rumination. Mindfulness doesn't just calm you in the moment. It physically rebuilds the neural architecture of emotional regulation. You can reshape your brain toward resilience. Physical exercise, particularly aerobic exercise, improves sleep quality through multiple mechanisms. Exercise increases adenosine accumulation, deepens slow-wave sleep, reduces anxiety, and helps regulate circadian rhythms through light exposure and temperature fluctuations. A 2024 systematic review in Sports Medicine analyzed exercise intervention studies and found that regular, moderate-intensity aerobic exercise, 30 to 45 minutes, 4 to 5 times per week, improved sleep quality, reduced sleep onset latency, and increased slow-wave sleep percentage. Timing matters. Morning exercise strengthens circadian rhythms by providing a consistent daily cue, while evening exercise raises body temperature, with the subsequent cooling phase promoting sleep several hours later. However, intense exercise within 2 hours of bedtime can be counterproductive for some people, increasing arousal when you need calm. Movement heals the exhausted mind and invites deeper sleep. But gentleness and timing matter. Exposure to morning bright light strengthens circadian rhythms and improves nighttime sleep. Your circadian system uses light as its primary synchronizing signal. The retina contains specialized photoreceptors called intrinsically photosensitive retinal ganglion cells that detect light and send signals to the suprachiasmatic nucleus. Morning bright light exposure, ideally within 2 hours of waking, at 10,000 lux for 20 to 30 minutes, advances your circadian phase, making you feel sleepy earlier at night. A 2024 study in sleep medicine had participants use bright light therapy boxes each morning for 2 weeks. Results showed shifted melatonin onset to earlier times, reduced sleep onset latency, and improved subjective sleep quality. Even outdoor time in natural sunlight provides benefit. Though the intensity varies with weather, light tells your internal clock when daytime begins, which helps it know when nighttime should start. Anchoring your rhythm to morning light creates stability in a chaotic world. Temperature regulation plays a crucial role in sleep initiation, and manipulating temperature can improve sleep. Taking a warm bath or shower 1 to 2 hours before bed initially raises core body temperature, but the subsequent cooling phase after exiting the bath mimics the natural temperature drop associated with sleep onset. A 2024 meta-analysis in Sleep Medicine Reviews found that passive body heating through bathing improved sleep onset latency by an average of 10 minutes and increased slow-wave sleep. The optimal protocol was a 104 to 109 degree Fahrenheit bath for 10 to 15 minutes, scheduled 90 minutes before target bedtime. Similarly, keeping the bedroom cool, around 60 to 67 degrees Fahrenheit, supports the body's natural temperature decline. Your brain interprets cooling as a biological signal for sleep. By working with your thermoregulatory system rather than against it, you can invite rest more easily. Sleep restriction therapy, paradoxically, can improve sleep quality by rebuilding sleep pressure. If you spend 10 hours in bed but only sleep 5, your brain associates bed with wakefulness and frustration. Sleep restriction temporarily limits time in bed to match actual sleep time, creating significant sleep pressure. Once sleep becomes more consolidated, time in bed gradually increases. A 2024 clinical trial in behavior therapy implemented sleep restriction with insomnia patients. Initially limited to 5 hours in bed regardless of sleep duration, participants reported feeling more tired, but paradoxically fell asleep faster and woke less during the night. Over 6 weeks, as time in bed gradually extended, sleep efficiency improved from 65% to over 85%. The technique rebuilds the association between bed and sleep while strengthening homeostatic sleep drive. It requires short-term discomfort but creates long-term healing by resetting your sleep system's responsiveness. Cognitive restructuring addresses the catastrophic beliefs about sleep that fuel anxiety. Many exhausted people believe that without 8 hours of perfect sleep, they cannot function, that poor sleep will ruin their health, or that they've permanently damaged their sleep system. These beliefs create intense bedtime anxiety. Cognitive restructuring challenges these thoughts with evidence. A 2024 study in cognitive therapy and research taught participants to identify and evaluate their sleep-related catastrophizing. Therapists helped them recognize that humans can function adequately on imperfect sleep, that one bad night doesn't cause lasting harm, and that sleep systems are resilient. Participants practiced generating alternative, balanced thoughts. This intervention reduced sleep anxiety and improved sleep quality independently of other changes. Your thoughts about sleep shape your experience of sleep. When you believe sleep is fragile and failure catastrophic, sleep becomes terrifying. When you trust your sleep system's resilience, sleep becomes approachable again. Building a consistent sleep schedule, even on weekends, stabilizes circadian rhythms and improves sleep quality. Your circadian system thrives on predictability. When sleep and wake times vary wildly day to day, your internal clock never settles into a stable pattern. A 2024 longitudinal study tracked sleep schedules and quality in over 1,000 participants for 3 months. Those with consistent schedules, sleep and wake times within 30 minutes variation day to day, reported significantly better sleep quality, less daytime fatigue, and better mood compared to those with irregular schedules. Even when total sleep time was similar, the consistency itself, not just the duration, provides regulatory benefit. Regular sleep times train your brain when to expect sleep, making the transition smoother. In a chaotic, unpredictable world, your sleep schedule can be an anchor of rhythm and reliability. Social connection and emotional support buffer against the sleep-disrupting effects of stress. Humans are profoundly social creatures, and our stress response systems are modulated by social bonds. A 2024 study in psychosomatic medicine examined the relationship between social support, stress, and sleep quality in healthcare workers during high-pressure periods. Those who reported strong social support, trusted friends, supportive family, understanding colleagues, showed significantly better sleep quality despite similar work stress compared to isolated individuals. Brain imaging revealed that social support was associated with reduced amygdala reactivity to stressors and maintained prefrontal amygdala connectivity. Connection provides resilience. When you face stress alone, your nervous system assumes maximum threat. When you face stress with others, your biology recognizes safety. Breaking the exhaustion sleep cycle sometimes means reaching outward, not just inward. Acceptance and commitment therapy teaches psychological flexibility, helping people respond to exhaustion differently. A CT focuses on accepting difficult thoughts and emotions rather than fighting them, identifying core values, and committing to value-driven action even when uncomfortable feelings arise. A 2024 randomized trial in Journal of Contextual Behavioral Science applied ACT to chronic insomnia. Rather than trying to eliminate sleep anxiety, participants learned to notice anxious thoughts without judgment, recognize that worrying about sleep was understandable but unhelpful, and focus on meaningful daytime activities regardless of previous night's sleep. This approach reduced the struggle against sleeplessness, which paradoxically improved sleep. Participants slept better not because they cared less about sleep, but because they stopped fighting their own minds. Exhaustion often involves wrestling with your internal experience. Acceptance invites a different relationship, observing without battle. Biofeedback training can help individuals gain control over physiological arousal. Biofeedback uses sensors to measure physiological signals: heart rate variability, muscle tension, skin temperature, breathing rate, and displays them in real time. With practice, people learn to voluntarily shift these signals toward more relaxed states. A 2024 study in applied psychophysiology used heart rate variability biofeedback to treat stress-related insomnia. Participants practiced slow, paced breathing while watching their HRV increase on screen, learning to activate parasympathetic tone on command. After 8 weeks, they showed improved HRV, reduced sleep onset latency, and better subjective sleep quality. The training gave them a tangible tool for shifting from sympathetic to parasympathetic dominance. Biofeedback transforms invisible physiology into visible information, offering agency over what feels uncontrollable. Limiting sleep-interfering substances like alcohol, nicotine, and caffeine improves sleep architecture. Alcohol may initially induce drowsiness through GABA receptor activation, but metabolism of alcohol produces acetaldehyde and causes rebound wakefulness, suppressing REM sleep and fragmenting the second half of the night. Nicotine is a stimulant that increases arousal and disrupts sleep maintenance. Caffeine blocks adenosine receptors, reducing sleep pressure for hours. A 2024 study in sleep health tracked substance use and polysomnography in social drinkers. Even moderate alcohol consumption, 2 drinks, within 3 hours of bed, significantly reduced REM sleep percentage and increased awakenings after sleep onset. Quitting or reducing these substances isn't easy, especially when they're used to cope with stress. But their impact on sleep is substantial and measurable. Sometimes improving sleep means removing obstacles, not adding interventions. Creating a sleep-friendly environment. Dark, quiet, cool, comfortable. Supports the biological conditions for sleep. Environmental factors powerfully influence sleep quality. Light exposure suppresses melatonin and signals wakefulness. Noise, even at levels that don't wake you, increases arousals and reduces slow-wave sleep. Uncomfortable temperatures prevent deep sleep. A 2024 intervention study in building and environment optimized bedroom conditions. Blackout curtains or eye masks, white noise machines or earplugs, thermostats set to 65 degrees Fahrenheit, and comfortable mattresses. Participants with optimized environments showed improved sleep efficiency. increased slow-wave sleep, and reduced nighttime awakenings compared to baseline. Your environment isn't just a passive backdrop. It actively shapes your nervous system's assessment of safety. A cave-like bedroom, cool, dark, quiet, signals to your ancient brain that this is a safe place to surrender consciousness. We now understand that breaking the exhaustion sleep cycle isn't about a single intervention, but a comprehensive approach addressing thoughts, behaviors, physiology, and environment. CBT-I restructures cognitions and behaviors, mindfulness and relaxation techniques, calm physiology. Exercise and light exposure strengthen biological rhythms. Social support buffers stress. Environmental optimization removes obstacles. Each element contributes, and synergy emerges when multiple strategies combine. Mental exhaustion creates sleep problems through multiple pathways. So recovery requires multiple solutions. There is no magic pill, but there is a map, an evidence-based understanding of what works and why. The path out of the cycle exists. It requires patience, consistency, and self-compassion, but it is navigable. Self-compassion, treating yourself with kindness during difficulty, reduces the shame and self-criticism that worsen exhaustion. When you sleep poorly, you might berate yourself. I'm weak. I'm failing. I should be able to handle this. This self-criticism activates threat responses, increasing cortisol and perpetuating the cycle. Self-compassion, by contrast, involves recognizing that suffering is part of the human experience, treating yourself with the same kindness you'd offer a struggling friend. A 2024 study in mindfulness taught self-compassion practices to insomnia patients. Compared to controls, they showed reduced bedtime worry, lower cortisol reactivity to sleep difficulties, and improved sleep quality. Self-compassion didn't magically fix sleep, but it removed an additional layer of suffering and stress. Being gentle with yourself when sleep is hard doesn't make you weak. It makes biological sense. Gratitude practices, reflecting on positive aspects of life, can shift attention away from rumination and promote calm. Gratitude interventions involve regularly noting things you're thankful for. Relationships, small pleasures, meaningful moments. This practice activates reward circuits, increases positive emotion, and reduces amygdala reactivity. A 2024 randomized trial in Journal of Positive Psychology had participants write down 3 things they were grateful for each evening before bed. After 3 weeks, they reported reduced pre-sleep worry, faster sleep onset, and improved mood upon waking compared to controls. Gratitude doesn't deny difficulty, but it balances perspective. When your mind fixates on problems, deliberately acknowledging goodness creates space for other emotions besides stress. A gentle shift in focus can quiet the internal storm. Meaning and purpose in life correlate with better sleep quality, independent of stress levels. Viktor Frankl's work on meaning-making during extreme suffering demonstrated that purpose provides resilience. Modern research confirms this extends to sleep. A 2024 longitudinal study published in Sleep Science followed over 4,000 adults, measuring sense of purpose and sleep quality annually. Individuals with high sense of purpose, feeling that their life has direction and significance, reported better sleep quality, less sleep disturbance, and lower rates of sleep apnea and restless leg syndrome, even when controlling for stress, depression, and physical health. Purpose appears to buffer against the sleep-disrupting effects of adversity. When your life feels meaningful, your nervous system interprets challenges differently, not as meaningless suffering, but as difficulty in service of something valuable. Purpose doesn't eliminate exhaustion, but it provides context that makes rest possible, even amid struggle. The concept of sleep opportunity versus sleep ability helps reframe insomnia. You may have adequate opportunity to sleep, time, a bed, safety, but lack the current ability to sleep due to hyperarousal, stress, or conditioned anxiety. Recognizing this distinction reduces self-blame. A 2024 conceptual paper in Sleep Medicine Clinics argued that insomnia is not a choice or failure, but a state where sleep ability is temporarily compromised by biological, psychological, or environmental factors. Treatment involves restoring sleep ability through addressing arousal, reconditioning associations, and rebuilding trust in your sleep system. When you frame poor sleep as "I'm choosing not to sleep" or "I'm bad at sleeping," you generate shame. When you frame it as "my sleep ability is currently impaired, and I can work to restore it," you create agency and hope. Language shapes experience. Therapeutic sleep deprivation, used carefully in clinical settings, can reset sleep systems. In cases of severe depression-related insomnia, controlled total sleep deprivation for one night, followed by recovery sleep, can provide rapid symptom relief and jumpstart circadian rhythm normalization. A 2024 study in Journal of Affective Disorders used wake therapy, staying awake for 36 hours. In treatment-resistant depression, patients with insomnia, about 50 to 60% showed immediate mood improvement in controlled studies. And combined with light therapy and sleep scheduling, many sustained benefits long-term. The mechanism appears to involve resetting circadian phase and increasing sleep pressure to overcome chronic hyperarousal. This is not advice to simply skip sleep. Therapeutic sleep deprivation requires medical supervision, but it illustrates that even severe sleep disruption can sometimes be reset through strategic intervention. Your sleep system, no matter how broken it feels, retains capacity for repair. Neuroplasticity, the brain's ability to reorganize and form new connections. PRAN means that chronic stress-related brain changes are not permanent. Earlier, we discussed how mental exhaustion reduces prefrontal cortex volume, disrupts connectivity, and increases inflammation. But the brain is remarkably plastic. A 2024 longitudinal study in neuropsychopharmacology tracked individuals recovering from burnout over 6 months with repeated MRI scans. With interventions, including stress reduction, therapy, improved sleep, and social support, participants showed measurable recovery, increased prefrontal cortex thickness, normalized amygdala volume, restored prefrontal amygdala connectivity, and reduced inflammatory markers. Their brains physically healed. Recovery takes time, weeks to months, not days, but it happens. The exhausted brain is injured, but not irreparably damaged. With the right conditions, it rebuilds. Hope itself has measurable psychological and physiological effects. Hope theory, developed by psychologist Charles Snyder, defines hope as the belief that you can find pathways toward goals and the motivation to pursue them. Hope isn't naive optimism. It's goal-directed thinking combined with agency. A 2024 meta-analysis in Clinical Psychology Review found that interventions increasing hope significantly improved depression, anxiety, and sleep quality. Brain imaging showed that hopeful thinking activates prefrontal goal planning regions and reduces amygdala threat responses. When you believe change is possible and you have some ability to create it, your nervous system shifts from helpless threat mode to engaged problem-solving mode. Hope makes rest more accessible because it reduces the existential terror that fuels sleeplessness. Believing recovery is possible is part of what makes recovery possible. Small, consistent changes accumulate into significant transformation over time. Behavioral change research shows that modest, sustainable modifications are more effective than dramatic overhauls. A 2024 study in health psychology tracked habit formation and found that tiny, daily practices, 5 minutes of morning sunlight, 3 minutes of deep breathing before bed, going to bed 15 minutes earlier, showed better adherence and greater long-term impact than ambitious programs requiring hour-long commitments. The brain's reward system responds better to frequent small successes than infrequent large ones. Moreover, small changes feel manageable when you're exhausted, while overwhelming protocols trigger avoidance. Breaking the exhaustion sleep cycle doesn't require heroic effort. It requires gentle, persistent adjustment. 1 degree of change, maintained over months, redirects your entire trajectory. The realization that rest is productive, not oppositional to productivity, transforms how we approach exhaustion. Western culture often frames rest as laziness, something to minimize in pursuit of achievement. But neuroscience reveals that rest is when the brain consolidates learning, strengthens memories, clears waste, repairs tissue, and integrates experiences. Without rest, productivity collapses. A 2024 organizational psychology study found that companies implementing mandatory rest policies limited after-hours email, encouraged breaks, protected vacation time, saw increased employee output, creativity, and retention compared to companies with always-on cultures. The exhausted worker who pushes through produces lower quality work than the rested worker who protects boundaries. Rest isn't the opposite of productivity. It's the foundation of sustainable productivity. Honoring your need for sleep isn't self-indulgent. It's strategic. So the answer to breaking the cycle is this. Mental exhaustion and poor sleep create a vicious cycle. But that cycle can be interrupted and reversed through evidence-based interventions addressing cognition, behavior, physiology, environment, and meaning. No single approach works for everyone, but the toolkit is rich and scientifically validated. Recovery requires recognizing that you deserve rest, that rest is possible, and that taking steps toward better sleep is not weakness but wisdom. The path exists. The brain can heal, sleep can return, and the exhausted mind can find peace. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. The planets orbit. The seasons turn. Your breath moves in and out. All are circles, cycles, endless returns. Like your breath, Inhale, exhale, inhale, exhale. A small cycle within the vast universe. You are also part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order, like planets silently rotating in their orbits. Unhurried, unresisting, simply existing. We're almost there now. Rest is not earned through productivity. It is a biological necessity that precedes and enables all achievement. Every creature that has ever lived required rest. Trees enter dormancy, bears hibernate. Even bacteria have circadian-like activity cycles. The notion that you must justify rest through accomplishment is culturally constructed, not biologically sound. Your worth as a human being does not fluctuate based on your output. You deserve rest simply because you are alive. Sleep is the most vulnerable state an organism can enter. Unconscious, immobile, unaware of surroundings. Yet evolution preserved it fiercely across species, suggesting benefits so essential they outweigh enormous risks. If sleep weren't deeply necessary, evolution would have found ways to minimize it. Yet even animals facing extreme predation pressure still sleep. The universal preservation of sleep tells us something profound. Life cannot exist without rest. The word exhaustion shares roots with exhaust, to empty completely, to drain. Mental exhaustion is the emptying of your internal resources. There is no shame in being empty. A well that has given water to thirsty travelers is not a failure. It needs time to refill from underground springs. You too need time to refill. Modern life moves at a pace human biology was never designed for. For most of human history, we worked with daylight and rested with darkness, lived in small communities with deep bonds, faced occasional acute stresses, but not chronic, unrelenting pressure. Your exhaustion isn't personal failure. It's a nervous system adapted for one world trying to survive in another. There is a difference between tiredness and exhaustion. Tiredness says, "I need rest tonight." Exhaustion whispers, "I have needed rest for months." Tiredness is a signal. Exhaustion is that signal ignored until it became a crisis. If you are exhausted, it means you have been setting aside your needs for a very long time. That can change now. Breathe slowly here. Sleep is the space where the conscious mind releases control and the body's ancient wisdom takes over. Your heartbeat, your breath, your cellular repair, your immune defense, your memory consolidation. None require your conscious effort. They know what to do. Sleep is trust. Trust that your body knows how to heal. Trust that letting go is safe. The concept of sleep hygiene can sometimes create pressure. If you've tried everything, the dark room, the cool temperature, the regular schedule, and still cannot sleep, you may feel broken. You are not broken. Sleep hygiene addresses obstacles, but it cannot force a hyper-aroused nervous system to surrender. Sometimes the most important practice is self-compassion when sleep won't come. Dreams are the mind's way of processing what cannot be processed while awake. Strange, symbolic, sometimes disturbing. Dreams take the emotional residue of your waking life and integrate it into narrative. When stress disrupts REM sleep, you lose this processing. Emotions accumulate, undigested. This is why exhaustion feels emotionally overwhelming. Sleep gives you that chance. The darkness you encounter at bedtime, The quiet, the stillness, is also the space where healing unfolds. In darkness, awareness deepens. In stillness, you notice what remains. Perhaps what feels uncomfortable is not the darkness itself, but what you might feel within it. Yet feeling is not dangerous. It is the path through, the way toward rest. Your brain's default mode network, which causes rumination when dysregulated, also creates meaning, imagination, and self-reflection when healthy. The same system that traps you in worry can also hold your dreams, your memories of love, your sense of who you are. Mental exhaustion hijacks this network. Recovery means reclaiming it for wonder. Let this settle. There is no such thing as perfect sleep. Even the best sleepers wake occasionally, dream uneasily sometimes, feel groggy certain mornings. The goal is not perfection but adequacy. Sleep that allows you to function, to feel, to heal, even if imperfect, is enough. Silence can feel threatening when you've filled every moment with noise to avoid yourself. But silence is not empty. It holds the sound of your breath, the rhythm of your heart, the quiet hum of existence. In silence, you remember you are more than your thoughts. You are the awareness in which thoughts arise and fade. Your body knows how to sleep. You did it as an infant without instruction. Even now, after months or years of insomnia, the biological machinery remains intact. Sleep is not a skill you learn. It is a letting go you allow. The harder you try, the more elusive it becomes. The more you trust, the more naturally it arrives. Every creature that sleeps is vulnerable. Every creature that sleeps trusts that the world will hold them safely while they let go. You too can trust. The sun will rise whether you sleep or not. Your problems will remain whether you sleep or not. But if you sleep, you will face them with a mind that has been washed clean, with a body that has been repaired. Mental exhaustion has changed how we understand sleep. We now see sleep not as passive downtime but as active restoration. We know exhaustion dismantles sleep architecture while demanding more from it. We know the cycle is cruel but breakable. Healing requires not just techniques, but a fundamental shift in how you relate to rest. Almost there now. The poet Rainer Maria Rilke wrote, "Perhaps all the dragons in our lives are princesses who are only waiting to see us act. Just once. With beauty and courage. Perhaps the exhaustion that feels overwhelming is actually your body's plea for you to stop abandoning yourself. Not a dragon to slay, but a message to heed. Rest is rebellion in a culture that worships productivity. To sleep when there is more work to do. To say I am enough when you feel you haven't achieved enough. To prioritize your well-being over others' expectations. This is radical. Your exhaustion might be the thing that finally helps you set boundaries you've needed for years. You cannot pour from an empty cup. This phrase has become familiar, but its truth remains. Every act of care you extend to others, every responsibility you carry, every challenge you face draws from your internal reserves. If you never rest, eventually you have nothing left to give. Resting is not selfish. It is how you sustain your ability to show up. There is a Japanese concept called kintsugi, the art of repairing broken pottery with gold, making the cracks visible and beautiful rather than hidden. Your exhaustion has cracked you. Perhaps the healing involves not returning to who you were before, but becoming someone new. someone who honors their limits, who treats rest as sacred. Time does not heal all wounds, but time with intentional care can heal many. Recovery from mental exhaustion is not instantaneous. It is daily choices, accumulated over weeks and months. It is going to bed even when your mind races. It is asking for help. It is trusting the process even when progress feels invisible. The moon waxes and wanes. The tides rise and fall. Flowers bloom and wither and bloom again. Nature is cyclical, not linear. You too are part of nature. Perhaps exhaustion is your season of winter. Necessary, temporary, preparing the ground for spring. Nothing blooms all year. The deepest truth is this: you are already worthy of rest. Not after you finish the project, not after you prove yourself, not after you meet the expectations. Right now, exactly as you are, you deserve to close your eyes and let go. Your value is inherent, not contingent. Somewhere tonight, someone else is lying awake, mind racing, body exhausted but unable to surrender. You are not alone in this struggle. Across the world, countless exhausted minds are seeking the same peace you seek. There is no judgment in this shared experience, only the quiet solidarity of fellow travelers. This video cannot give you sleep. No words, no facts, no techniques can force your nervous system to do what it is not ready to do. But perhaps it can give you permission. Permission to rest without guilt. Permission to struggle without shame. Permission to seek help without feeling weak. Permission to believe that healing is possible. The real change isn't in sleep itself. It's in you. It's in recognizing that you have been at war with your own exhaustion. And that war has only made you more tired. The change is in laying down arms. In treating yourself as you would treat someone you deeply love who is struggling. In whispering to your weary mind, "You have done enough. You are enough. Now rest." And so, our quiet journey through mental exhaustion and sleep comes to a gentle close. We've traveled from the accumulation of glutamate in exhausted neurons to the disruption of REM sleep architecture, discovering along the way that tiredness is not weakness but biology speaking truth. From the hyperactive amygdala that keeps you vigilant in darkness to the self-compassion that finally allows surrender, we've glimpsed how mental exhaustion is both devastating and deeply, profoundly human. Mental exhaustion reminds us that we are not machines designed for endless output, but living organisms requiring rhythm, rest, and renewal. Much of the healing happens in stillness, in the darkness behind closed eyes, in the vulnerable act of letting go. Sleep reveals our fundamental need for surrender, for trust, for the humility of admitting we cannot do everything alone. Without rest, even the strongest mind crumbles. By pausing to notice, we glimpse the extraordinary resilience hidden within our ordinary need for sleep. In these final minutes, take the deepest breath you can, as deep as possible. Think about the unity of every atom in a black hole, where all boundaries dissolve. Light, matter, time, all becoming one. You too can dissolve into sleep like that. No boundaries left between you and rest. Think about consciousness itself. Yours, mine, everyone listening. All awareness everywhere, perhaps all connected in ways we don't yet understand. You are not alone in the universe of minds. Let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought. Prepare for deep sleep. No boundaries left, only peace. If this thoughtful exploration of the mind made you relax, fall asleep, or sparked curiosity tonight, a gentle like and subscribe helps other sleepless souls discover this peaceful space too. It only takes a moment, but it means the world to us. One quiet tap, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, farther than most journeys take you. You can allow these thoughts of exhaustion and sleep to fade now, like morning mist dissolving in sunlight, leaving only the gentle calm behind. Let your breathing deepen. Let your body feel heavier, as if gravity itself is gently pulling you down into the mattress, into the earth, into safety. If sleep comes, let it carry you like a slow river current, smoothly, inevitably, into a realm where time and weight and worry no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, your thoughts will still be there. Your challenges will remain. But tonight belongs to stillness. Rest well, weary traveler, and remember, your exhaustion is not your identity. It is a temporary state, a signal, a call to care. You have permission to answer that call. Fall asleep to gentle facts, where science meets sleep. Dream deeper with bedtime science. Relax, listen, and drift into sleep. Good night.